Science 8 readings for Lesson 4.1 WCS. The name of this article is, Why Does the Wind Blow? The purpose for reading this article is to answer the question, how is wind formed? What makes the wind blow? From light breezes to strong gusts, winds get their start as a result of uneven heating of Earth's surfaces. So the article has answered the question pretty quickly. Why does wind blow? Wind blows because of uneven heating of Earth's surfaces. It's also said down here. So I would underline it, circle it, star it, because it's a pretty important concept. Wind is simply air in motion. The process begins as the sun warms Earth. As the layer of air above a warm surface heats, it expands, becomes lighter, and rises. As the warm air rises, it expands and eventually cools. The dense cold air moves in to replace the rising warm air. Earth warms this layer of incoming cool air, and it also rises and then is replaced by another layer of cooler air. This cycle goes on and on. The circulating flow of air resulting from temperature differences is called a convection current. Convection currents can form in liquids too. Later in the unit, you will investigate convection currents in the ocean. Can you speculate about the causes of convection currents in the ocean? So if you could please circle the word wind and know that wind is just moving air. If you could also please circle the word convection currents and know that a convection current is air moving in a circle because of uneven heating. So if you notice the picture to the right, it is a convection current. Because if you notice, it is air that is making a circle. So first, the sun warms up the land and the air. Next, the warm air expands and rises. Next, the warm air cools. Next, the cold air becomes dense, which means heavy, and it sinks down to the ground. Finally, that cold air replaces the warm air, and the circle begins again. Where the sun warms up the land and air, it rises, then it cools. The cold air is dense and heavy and sinks. The cold air then replaces the warm air. And when the cold air is replacing that warm air, that causes the breeze. Remember, this is a convection current because air is going in a circle because of that uneven heating. What are monsoons? Monsoons are very powerful land and sea breezes that change directions with the seasons. They occur mostly in southern Asia and equatorial Africa and are an important part of life there. So if you could please circle the word monsoon and know that they're just very powerful land and sea breezes. During the summer, the air over the land heats up. As the hot air rises, it is replaced by cooler, moist air from the Indian Ocean. In turn, this moist air is heated and rises. The water vapor in the rising air condenses, forms clouds, and produces rain. The cycle repeats throughout the season, bringing long periods of rain to the region. During the summer, people grow rice and other crops that need a lot of moisture. So remember, in the summertime, the land gets warmer more quickly. So what happens is that the air on top of the land goes up. The cool air that has lots of moisture in it from the water replaces that land air that's gone up. As the warm air is going up, it condenses and makes clouds. So a lot of moisture in the clouds causes rain. As the warm air is going up, it cools, gets heavy and sinks, and goes back down over the water. And then it continues that cycle over and over again. And so it rains a whole bunch over land. So what happens is because it rains so much, it allows people to grow lots of rice and other crops that need a lot of rain. So in Asia, people grow a lot of rice because there's a lot of rain. Now in Asia in the winter, it's opposite. The water is warmer. So air over the water rises, then it cools and sinks and goes over land and then goes back. So that's a convection current. And because there's not a lot of moisture, what happens is it just has very little rain. Notice the picture to the right. You'll notice that there are people that are trying to make their way through a flood from the monsoon in India. So you know this is a picture from the summer because monsoons happen in the summertime. Please turn the page. Land breezes and sea breezes. Land breezes and sea breezes are both caused by convection or the movement of heat through air or water. These breezes occur when large bodies of land and water meet. The different rates at which land and water heat and cool causes these winds. So please circle the word land breezes and know it's wind going from the land to the ocean. Also, please circle the word sea breezes and know this is wind that blows from the sea to the land. During the day, land warms up faster than the water in lakes or oceans. Warm air rises above the land, forming an area of low pressure, and this allows the cool, dense air over the water to slide in and push aside the less dense warm air. This flow of air is called a sea breeze. So this section is basically telling you how a sea breeze is made. If you look at the picture of the sea breeze, you'll notice right away this is a convection current. It's going in a circle again, right? So in a sea breeze, the first thing that happens is that sun warms the land and the air above it. Then that warm air rises. Then the warm air cools. The cold air is dense and it sinks down. And then that cold air replaces the warm air. That movement of cold air from the ocean going to warm air on land is causing your sea breeze. And so during the day at the ocean, the breeze is always coming off of the water and onto land. At night, the land cools faster than the water, so the air over the land becomes cooler than the air over the water. As the warm air over the water rises, cool, dense air from the land moves towards the water and pushes warm, less dense air aside. The flow of air from land to water is called a land breeze. So basically, this is how a land breeze is formed. So let's look at this picture of the land breeze at night. If you'll notice, the water is warmer. So the warm water rises, or the warm air above the water rises. Again, the warm air rises. It starts to cool, gets cold, dense, or heavy, and it falls. or sinks. Then you have the cold air that's over the land that replaces the warm air over the ocean. So what happens here is that with a land breeze, particularly at night on a beach, you're going to have the wind blowing off of the land and into the water. And that's because you have warmer water over the ocean that rises, cools, finally sinks over the land, and then that colder air replaces the warmer air. Notice also that this is a convection current. Again, it's going in a circle. While this helps explain why there always seems to be a breeze at a beach, what causes winds everywhere else? Air pressure and the Coriolis effect. The uneven heating of air on Earth can also cause areas of high and low pressure over any surfaces. As air is warmed, it begins to expand, becoming less dense and rises. This lowers the pressure at the surface of Earth. The opposite is true of air that is cooled. It contracts, becoming dense, and the pressure at the surface increases. So basically what's important here is that cold air is going to cause, because it's going down, it's causing a lot of pressure on the surface of Earth. And so we call that a high pressure. And you'll notice the H with the circle around it, that's how we write high pressure. And the warm air, because it's going up and expanding and it's going up, that's low pressure because it's not pushing down on the Earth. And so we call that an L with a circle around it. So basically, cold air causes high pressure and warm air causes low pressure. Air moves from areas of high pressure to areas of low pressure, which can cause local winds. The same phenomena is observed when you inflate a balloon and then release it. The air inside the balloon is at a much greater pressure than the air outside the balloon. Once the balloon is released, the air inside rushes out, creating the effect of wind. The larger the difference in pressures between two colliding air masses, the higher is the wind speed. So we're all not next to a beach, but air still moves. And that's because air moves always from a high pressure to a low pressure. And that movement of high pressure to low pressure causes wind. So if you look at the picture of the sea breeze, since the air is going up, you have a low pressure here because it's not pressing down on Earth. And then over here in the colder area, you have a high pressure because that air is pushing down on Earth. And the greater the difference between this high pressure and low pressure, the more wind you're going to have. If the difference between the high temperature and the low temperature, or the low pressure is, the smaller the wind. If the high pressure is really high and the low pressure is really low, you can have lots of wind. So the bigger difference between the high and the low, the more the wind is. Please turn the page. While winds blow from an area of high pressure to an area of low pressure, they do not always move in a straight line. This is due to the phenomena that causes fluids like water and air to appear to deflect to the right in the northern hemisphere and to the left in the southern hemisphere, described as the Coriolis effect. It is caused by Earth's rotation. Earth is constantly spinning on its axis, rotating from west to east, and it takes 24 hours for Earth to make a complete rotation. Because Earth is wider at the equator, it rotates faster at the equator than it does at the poles. So if you could please circle the word Coriolis effect and know that winds don't blow in a straight line because the Earth rotates. So if you could please draw this drawing of the world, and you have the northern hemisphere and you have the southern hemisphere. So in the northern hemisphere, the winds look like they go to the right because the equator is warm and warm air rises towards the poles. In the southern hemisphere, the winds appear to go to the left. And that's because the Earth is rotating. Global winds. Other winds do not just blow locally, they are continually forming around Earth, moving in a particular direction, always to the east, for instance, and traveling over long distances. These winds, which form between the equator and the poles, are called global winds. So if you could please circle the word global winds and know that these are winds between the poles and equator. The equator and the poles are not heated evenly. Near the equator, the sun's rays are more direct and more intense. This is what makes the tropics so warm. Near the poles, sunlight falls on the surface at an angle and passes through more atmosphere to reach the surface. Since the atmosphere both absorbs and reflects the sun's heat, less light hits each square meter of surface at the poles than at the equator. The result is that the poles are not as warm as the tropics. Recently, however, scientists discovered that the polar regions are absorbing heat at an increasingly rate as Earth's climate changes, particularly as please turn the page, ice melts and sunlight strikes dark ocean rather than white ice. This change is already having a significant effect on the ecosystems and living things in the polar regions. Global winds are the result of a giant convection currents that circulate within the northern and southern hemisphere of Earth. As warm air is heated at the equator, it rises and flows both north and south towards the poles. If Earth didn't rotate, the hot air at the equator would rise to the poles, cool, sink, and flow back to the equator again. But Earth does rotate, which means that air and water currents on Earth are deflected. Trade winds, westerlies and easterlies, are named of different global winds that form because of Earth's rotation and the sun's energy. Trade winds flow towards the equator, turning west as they go. Westerlies flow from west to east. These winds are called westerlies because they flow from the west. For example, polar westerlies are winds that flow towards the poles, turn east as they go. Easterlies flow from east to west. These winds are called easterlies because they flow from the east. For example, polar easterlies are winds that sink at the poles, spread outward, and turn west as they go. What happens when these global winds meet? Where the westerlies and easterlies meet, weather changes occur. The meeting of the westerlies and the easterlies has a major effect on the weather that occurs in North America. Please turn the page. Jet stream. Strong winds in what is called the jet stream are long, relatively narrow tubes of air in the boundary between the troposphere and the stratosphere. They form at various latitudes from the equator to the poles, where Earth's curvature produces cooler zones next to relatively warm zones. Located about 10 km, 6 miles above the ground, and meandering in their paths, the jet streams are only a few hundred kilometers wide, but they sometimes stretch halfway around Earth. Jet stream winds usually travel at about 200 kilometers, 124 miles per hour. but can move twice that fast. They were discovered by American pilots during World War II, although some 19th century scientists speculated about their existence. Jet streams and their paths vary from day to day and season to season. These powerful winds play a large part in moving air masses around Earth, which means that they also play a bigger part in determining Earth's weather. Forecasters can use the path of a jet stream to predict how weather will move across the country. End of recording.